Hi everybody! Welcome back to another episode of the STEM Space at Home, a series of engineering challenges for all ages using materials you can find at home. My name is Natasha, I'm an aerospace engineer, and I'm going to be your conductor for today's musical challenge. But first, how well do you know your instruments? We're going to take a little quiz. I'm going to play a sound, and you're going to guess what instrument makes that sound. How'd you do? Can you think of any other instruments, or is there an instrument that you love to play? But how do all these instruments make the music that we love to hear? In today's video, we're going to talk about the science behind sound, and then you'll get a chance to create your own musical design. Let's get started. Sound is all around us. You just listen to several different instruments. Sound is the birds chirping outside, your dad snoring. What other sounds can you think of? All those sounds are a type of energy caused by vibrations or something moving back and forth. When that happens, it causes the air to vibrate, and that vibration moves in the form of a wave that gets to your ear, and then you can hear the sound. So no matter if it's a drum beating or someone plucking a guitar, it's all caused by vibrations. One great example is the sound of my voice. It's caused by my vocal cords vibrating the air as it moves from my lungs to what you hear. You can actually sense those vibrations. Put your hand on those vocal cords, try talking or humming, and you can actually feel it. The same is true for a guitar. When you pluck a string, you can cause that string to vibrate, and that's what produces the sound. Here's a really cool video of that in action. Someone placed a camera inside of the guitar, and so you're looking at the strings vibrate as he plays the song. And notice the different types of vibrations making different types of sound or notes. Let's do another trivia question. Can you hear sound in space? In order for sound to travel, it needs something to travel through. We've talked about how vibrations can travel through air, maybe when you pluck a guitar string. But what about underwater? If you've ever tried yelling underwater, you can actually hear it because sound can travel through the water. Or if ever you've pressed your ear against a door, you can hear the sounds on the other side. Sound can actually travel through any gas, liquid, or solid. It just needs something to travel through. What about in space, though? There's actually no molecules in outer space for sound to travel. There's a few, and they're very far apart, so the vibrations don't propagate or make it through space for us to hear. So whenever you drop something or throw something in space, you're actually not going to hear it. But for today's challenge, we're here on Earth, so we have air and other mediums that sound can travel through. Our job is to control that sound. Let's get started. For today's challenge, you're going to be acoustic engineers. That's a type of engineer that focuses on all things sound. They design, they study, they control the vibrations to create the sound that they want. One example is reducing the level of sound. So if you live near a highway, it might be annoying to constantly hear the sound of cars passing by or cars honking. Acoustic engineers design ways to absorb that sound. Maybe they have a large wall that blocks your house from the highway, so it absorbs those sound waves or make them not as loud. Other times, acoustic engineers want to make things louder. Acoustic engineers are involved in designing an auditorium or a concert hall. They want to make sure that everybody in the audience can have the best sound experience. So next time you go to a rock concert, you can thank an acoustic engineer. For our first challenge, we are going to design an instrument that controls the loudness of the sound. The energy or loudness of the sound can also be measured through decibels. Something with a greater decibel value is louder, and something with a smaller decibel value is quieter. So take a deep breath. The sound of your breath is about 10 decibels. Someone talking to you, that's about 50 decibels. You can actually download an app on your phone that's called a decibel meter, and you can use your phone and measure the level of different sounds around you. Next, we need to brainstorm some solutions. How can we use the materials in our house to create sound? I recommend looking at different instruments to get some inspiration. How does the drum work? Here's an example of a drum. When I hit the drum, I'm creating a sound. What about this one behind me? What's happening is by hitting the drum, I'm causing vibrations on the surface, and that's creating our sound. When I barely tap it, it makes a quieter sound. When I give it more energy, I'm creating a louder sound. What about this tambourine? When I shake the tambourine, I am causing the metal pieces to hit against each other and vibrate. That's what's causing that sound. Or the guitar we looked at earlier. Plucking those strings was causing vibrations on the string. Are you seeing a pattern here? So for this challenge, you need to find materials that create vibrations that can be turned into sound, and that by changing the energy we put into the instrument, we can change the amplitude of the wave or increase the volume of the sound. For the next part of this challenge, we're going to create an instrument that can make different notes. We're going to do that by controlling something called frequency. Let's look at some examples. Here is a kid's xylophone. Notice how the sound changes when I hit the different metal strips. Another example is this instrument. It's actually made out of bamboo, and you'll notice there's different lengths of bamboo. Remember how sounds are vibrations? The frequency of the vibrations, or the number of vibrations per second, determines the pitch that we hear. So a higher frequency means more vibrations per second. That means a higher pitch. A lower frequency, which means a lower number of vibrations per second, means a lower pitch. Generally, things that are smaller or lighter have a higher frequency compared to something that's bigger or heavier. One way to think of it is a squeak of a tiny little mouse versus a roar of a lion. That lion has a much lower frequency and it's a larger animal versus the tiny little mouse with a high-pitched squeak. So on an instrument, we can control the pitch by controlling the vibrations. Let's go back to that video of those guitar strings. Notice how the strings have different widths. Thicker strings have a lower pitch. Tightening the string will increase the pitch. You can also increase it by shortening the length of the string. So this lets you play different pitches with a few strings. So again, controlling the pitch is about the tightness of the string and the thickness of the string and the length of the string. You can do the same thing with a rubber band. Try stretching the rubber band between two fingers and plucking, just like a guitar string. You can actually hear a sound from the vibrations. So as you brainstorm ideas for this part of the challenge, once again look at different instruments for inspiration. The guitar can be replicated with rubber bands by changing the thickness or the stretchy tension of the rubber band. Maybe you're inspired by the xylophone that uses different lengths of metal to create different sounds. You could also look into wind instruments. This is a recorder. Whenever I change the distance that the air has to travel through, it changes the pitch of the note. Best of luck, everybody, in creating your own unique musical instrument. I hope you'll share your designs using the hashtag STEMspaceAtHome. Good luck, everybody, and we'll see you next time.